All right. Yes, class. Is this audible? Samaira, Sneha.
Yes, sir.
All right. Only 2 students are there right now. All right. Where are the other students? They might be joining them. Let's just start with it. So in the last class, we had completed till here. All these motions that we had seen, the path of the charge in a circular motion. Circular motion was basically the third case. There were different cases that we had seen. This was the last case, helical one, fourth one, where neither 0 degree was made nor 180 degree was made, and also not 90 degree was also not made. Lorentz force, we had actually not started with it. Let's just start with Lorentz force. See, if a charge is moving in a region that is having magnetic field and that is also having electric field, both the fields are there, magnetic field as well as electric field, then the force that will be experienced by the charged particle, that will be known as Lorentz force, and it will have the component of magnetic field as well as it will have the component of electric field. Both the fields will be there, electric field component and this magnetic field component. And that force, see electric, let me write down the first, the Lorentz force. If charged particle is moving in a region, it's moving in a region that is having, see, only electric field, we have done it in the first lesson, and only magnetic field we have covered it till the last class, that is having both magnetic field as well as electric field. Then it may experience electric and magnetic, both the forces. Then it may experience both electric and magnetic force. And this is known as Lorentz force. Basically, this electric and magnetic force, this is known as Lorentz force. So electric force is what? Electric force is basically QE, charge multiplied by the electric field. That is known as your electric force. And what was your magnetic force? Magnetic force, in the last class we have studied what was magnetic force. Magnetic force formula, do you remember? In the last class we had done it. So magnetic force was charge and V cross B. This was the magnetic force. So electric force was QE. Hania, you're not able to connect your audio. So electric force is charge multiplied by the electric field. Magnetic force is charge multiplied by the cross product of velocity and the magnetic field. So both of these forces exist. Hania, are you able to hear your connection?
Yes.
All right. So Lorentz force basically says what? Magnetic field is there, electric field is there. So in both the regions, in our region, if both the fields exist, then we cannot neglect electric force, we cannot neglect magnetic force. So ultimately what will happen? The net force will be sum of electric force as well as the magnetic force also. So these are the two forces in nature, electric force and magnetic force, that we will discuss, and net force on it will become the sum of both the forces. One more thing I wanted to ask you people, is the app working right now well? Because many students have complained about the app. So I want to ask about this batch. Students, just tell me about your app. Are you able to receive the assignment? Is there any issue? Whatever is the issue, just text me in the chat box. I'll read it out if there is any issue. It's not working for you, Sneha. All right. If any other, what is it saying? Subscription has expired, system under control, or it's not opening. Just tell me the reason. I'll share your complaint there also. What happened? Students have joined late today. All right.
Ma'am, me and Salman had maths class.
Okay. All right. Your maths extra school class.
Tuition.
This Learnivio.
No, separate.
Okay. All right. Fine. You're not able to submit the assignments. You're able to receive it, Hania, but uploading portion is not being done.
Yes, ma'am.
All right, I'll see to it. It's under setup. 4 days. Sneha, did you create another account? Just tell me all of you. You didn't create another account. You had the only initial account. Huh? All right. Just tell me all the complaints. I'll then pass on the complaints together because class 11 students are also complaining about some issues in the app. So whatever issues you people have, just text me. Otherwise, assignments I am giving them questions to send you people. Sometimes there are questions very relatable to the class. Sometimes there are very few questions. Sometimes there are 5 questions. So I'm not able to get the whole response by the whole class. So if you're not able to submit it, some students I have received, like Samira's that assignment I have received. Khalid has submitted me those assignments on WhatsApp personally. But if any one of you is having issue, just text me like Sneha did, Hania did. If others are also having issue, just let me. So net force will be what? We were discussing that in a region, a charge is moving and it has electric field as well as magnetic field. So what type of force will exist? Electric force is also there, so it should also exist. Magnetic force is also there, that we studied, Q, V cross B, that should also exist. So which force will be produced in nature? Net force will be, we cannot neglect any of the forces. Net force will actually be sum of all the forces that are present. So net force, and this force is known as Lorentz force. The Lorentz force, by the name of the scientist Lorentz, he actually discovered this and did all the experiments regarding this. So net force will be what? This will be QE plus V cross B. QV cross B. Both the forces. From here, if you take Q common, this becomes E plus V cross E plus V cross B. This is your Lorentz force. This force is known as Lorentz force. So how to identify when to use all of these formula? You have studied so many forces right now. When to use this one? You will be studying more forces. BIL will also come. E is equal to BLV. Many things will come. So how to figure it out? If electric field is given, magnetic field is given, simply use this. No need to ignore anything or neglect anything. If it is mentioned, use both of them. So this is actually Lorentz. This is known as the Lorentz. Direction of electric force we have studied. Direction of electric force, you know, no? I hope you people remember it. Let's just revise it. Just you can make a note point and write. This is the direction of electric force. So if it's a positive charge, and this is the direction of electric field. For a positive charge, the direction of force is same as that of electric field. Remember, we had derived those torque expressions for a dipole. So when we took force on the positive charge, we took it as plus QE. And similarly, for the negative charge, the direction becomes opposite to that of electric. If this is a negative charge, minus Q. This becomes the direction of force, that is minus QE. Regarding the magnetic force, Magnetic force, in the last class only we had studied it. Magnetic force direction was given by right hand thumb rule. You have to place your fingers in the direction of velocity, curl your fingers towards magnetic field, and the direction of thumb gives you the direction of magnetic force. So this is given by right hand. We'll do a question on it in vector form, because I don't think so we have discussed in this batch the Cartesian form vectors, cross products. When we have only discussed the normal one with putting sine theta in the planar form. So let's do it for Cartesian form. I'll give you the question in terms of Cartesian form. Cartesian form, I hope you understand. I cap, j cap, k cap in terms of this. Like electric field will be 5 I cap plus 2 j cap, like this. So will V cross B, there you have to form the complete determinants. Fine. Just note it from here. I'll give you the question once you write it down. So only Samira's got the answer. 8 I cap minus 12 J cap minus 10 K cap. All right. Any other answer coming? Should I discuss it then? Is this V cross B that you're getting, Samira, or the complete answer, the whole force? Or is just that V cross B?
Ma'am, the complete answer.
Now V cross B first we have to find, because once you have found V cross B, then the whole question solving is easier. So I think no more answers are coming. Only one student has tried the question. Any answer coming? Let's discuss it then. See, when you have to take the cross product and it's given in terms of Cartesian form like I cap, J cap, so you have to form the complete determinant to find out the answer. How will you find V cross B? It's V cross B. So see, make the determinant form I cap, J cap, K cap, this column. Whatever is included in I, first term is V. So we'll write V. I's coefficient is 1. What is the coefficient of J? Minus 2. This you must have studied already in class 11th, when you must be doing vectors and all these basics, calculus and everything. So if there is any issue in this, ask me again. I'll repeat it. So, but right now I'm discussing it. K cap is not here, so it will be 0 for it. Now, second one is B. So we'll write everything for B. This is plus 1. J's coefficient is minus 1. K's coefficient is minus 5. All the coefficients I have written it. Now I have to find out the final answer. How to solve it? See, V cross B, because V cross B only needs determinants form. V cross. So V cross B only needs it. Otherwise, then rest of this is addition. Electric field will get added. So V cross B will be what? Firstly, write I cap. Now, whatever is there apart from I cap, cut it. Cut this whole row, cut this whole row of I cap. You are considering I cap right now. So cut the row of I, this whole heading, and cut the row of I cap. Now cross multiply this. First cross multiply this. What do you get? You get minus 2 multiplied by minus 5. I'll write down everything right now. Minus 2 multiplied by minus 5. Fine. Then cross put a negative sign and then cross multiply the other two. So minus 1 into 0 will obviously be equal to 0. This is the first one. For J cap, we already put a negative sign when we are using it for J cap. So for J cap, what will it be? For J cap, you have to cut the row of J cap. Cut this row now. Whichever one you're using, no, cut that row. Cut that row means ignore the row. You don't have to use the numbers for there. Now multiply this. I multiplied by minus 5 and then minus 1 into 0. So firstly, this 1 multiplied by minus 5 gives minus 5. Minus, what is left? 1 into 0 is again 0. And the last one again, for K we write plus. J only, remember, we write negative. Anyone who is having difficulties in this cross product, ask me. I'll repeat the basics, or you can even join the basic classes for it also. We can have a class on this. But I think many of you people must be knowing this. Now K cap, cross the row of k cap. What you have to do? First this, then this, with a negative sign in between. So this becomes what? Firstly, this is 1 into minus 1, that is minus 1 minus. What is this? Minus 2 into 1, that is minus 2. We have the whole V cross B right now. So see what it is. Minus 2 into minus 5, that gives 10 I cap, minus 0, nothing. Minus 5 into minus j cap gives plus 5 j cap. And here we have minus 1 plus 2. So 2 minus 1, that is 1. That is plus k cap. So V cross B is this. First, tell me anyone who is having difficulty till here. Then I'll solve it further. Anyone who is facing issues till here. Clear to all of you? Yes or no?
Yes.
Clear.
All right. So V cross B, if you have, now what? Now the question is easy. You just have to, what was the formula? E plus V cross B multiplied by the charge multiplied by E plus V cross B. So charge was 2 coulomb. Electric field was also given in terms of Cartesian form. I cap minus j cap. 2 I cap minus 3 j cap. Electric field is given 2 I cap minus 3 j cap plus. What is V cross B? V cross B is 10 I cap plus 5 j cap plus k cap. This term getting multiplied by charge. So 2 I cap plus 10 I cap, that becomes 12 I cap. Rest of the thing will be the same. No. J cap is here. So 5 j cap minus 3 j cap becomes 2 j cap. K cap is there. Nothing is there for k cap. So k cap plus 0 becomes k cap only. So multiply this term. 24 I cap minus 4 j cap plus 2 k cap new. This is your answer. That's how you solve these questions. All right. So note it down. If you're not able to understand, ask me. I'll repeat it. Notes. Plus 4 j cap where? Have I written anything wrong? Just check. Plus 4 j cap where is it? Minus 1. 2 minus 1, that's 1 j cap. Minus 5, so that's 5 j cap. Or are you saying that you were getting this answer in your answer? Are you saying this?
Yes.
Okay. All right. Means there must be slight error in the calculations, no? The basic formula and everything you must have utilized correctly. All right. Sir. All right. Okay, plus 4 j cap you were getting. Fine, I get it. Just let me know when you people have written it, the writing part. Then we'll start with another formula. One more formula regarding the forces left. Then for a single wire. Yes, we'll do velocity filter. Velocity filter basically selects the certain particles. Velocity filter is actually not now included in your course. Earlier it was included, the derivations in the formula used to come. Velocity filter acts as a filter basically. Means filter word you people understand, no? Filter word means what? To select something and to reject something. One thing gets accepted, other thing gets rejected. So velocity filter in your class 12 syllabus, it's basically it removes interfering signals by, there's a difference between the traveling velocities of different waveforms, and undesired interfering signals also come in. So we have to remove the undesired signals because we require which one? The desired waveform signals. So that's why we require these velocity filters. So basically velocity selectors, which are velocity filter, and this is also known as velocity selector. In NCRT, I think velocity selector is mentioned. I don't remember it. So velocity selector uses your electric field, it uses your magnetic field, both to select the charged particles of a particular velocity. Different charge particles move with different velocity because it's essentially a filter, no, only that allows particles with the same velocity to come out of a gate-like channel has been created. Gate-like channel is already there. So that's how velocity filter works. Basically, perpendicular velocities are allowed. Electric field and magnetic field lie perpendicularly this way. You have a whole setup for it. Yeah, so basically it's not like a device. It's a device, but you don't have a full apparatus and wires and everything connected. No, simple. It's just it's on the basis of the principle of a motion of a charge in a uniform magnetic field. So motion of a charge we have already studied in the last class. Clear, Seth?
Yes.
Others written? Shall we move forward?
Yes.
All right, if anyone is writing, just let me know. So what's the next? Then yes, the next topic is force on current carrying conductor in a magnetic field. Means magnetic field lines are there. Magnetic field lines are there, and a current carrying conductor is kept. We'll be doing force on two parallel conductors as well. That has a different formula. So remember, this is for just a single conductor. If you have two conductors, no, using this formula, we'll derive it. We'll do it in today's class only. That is simple formula. You people will be able to do it. This will be used. So this is the basic. So just understand this clearly. Others will be easier for you to understand. Let's say L is the length of this conductor. Let's say L is the length of this conductor. A is the area of this conductor. Electrons are allowed to move. Electrons are allowed to move. Now L is the length of, let me write this. Let me write this first. See, L is the length of this conductor, A is the area of cross section, I is the direction of current. Let's say electrons are moving in this direction. The charged particle is moving in this direction. So what is the direction of current? Direction of current is opposite to that of the negative charge. So this becomes the direction of current. Let's say with V velocity it's moving. Drift velocity is this. Any velocity that it's moving. Now small n, this is the number density. This is basically the number density. Density of electrons. Number density, remember we have used this term density. Number density basically means electrons per unit volume. Whenever this density term comes, this usually means anything divided by volume. Like energy density, we did it in terms of capacity. That was energy divided by volume. So this is basically electrons per unit volume. Electrons per unit volume. So what will be the volume of conductor? Can anyone tell volume of this conductor? All the data has been mentioned to you. Volume of the conductor.
Area into length.
Yes, area. Exactly. That will be area multiplied. V will be area multiplied by the length. Now, if this is for a single one, number density is what? N we have taken. That's a small n we have taken. So obviously we have to multiply for total electrons. We have to multiply it with n. So NaL will be the total number. That becomes the number density. All right, NaL. This is the number density. Al was the volume for a single one. For total electrons, the whole volume becomes this. Now, applying the Lorentz force that you have studied, Lorentz force, let's say, charge is what? Charge here is the electronic charge minus E, and drift velocity becomes the velocity because we have studied the velocity with which all the electrons drift towards the positive terminal. That is known as drift velocity. So the velocity here will become Vd cross B. This is the magnetic force. Let's just write the magnetic force first. This is basically the magnetic force. Now the total force on all the electrons, that will be this term getting multiplied by all the electrons. So see, total force will be total force on all electrons. Total force on all electrons, this will be the net force. Not let me write some other variable for this. Otherwise, both of these forces. Let me write small f for this, so that you're able to understand this force was not the total force. This was the force on a single electron. Let me write it with small f. So total force will become what? It will become NaLe. This NaLe, then Vd cross B. This much. If you put in the value for all the electrons that are present, that becomes NaLe Vd cross B. From here, if I ask you, if you look at this carefully, NeA Vd. Can anyone tell me what is this quantity?
Current. Current.
Yes, current. I is equal to NeA Vd. We did it, no? Remember, I is equal to NeA Vd. So current actually comes out and L remains in the bracket. So your final formula, this is a very important formula, and this will be used. This will be used throughout. In the magnetics only, it will be used. So the whole formula will become FB. This will become what? I'll write NeA-Vd together and I'll write L cross B here. So this I'm writing it as current. So total force becomes I into L cross B. So FB is also written as ILB sine theta. So theta is the angle between L and B. So this is the magnetic force acting on current carrying wire. This is basically, this is the force acting on current carrying. So this formula, we'll use it. We'll do a question. Let me give you a question first. Or you do one thing, you start noting from here. Once you reach here, then I'll give you a question based on this formula. This is for only single conductor. If you have more than a single conductor, two parallel conductors are there. That has a separate case. We'll do it. The formula becomes slightly changed because force is exerted on the other one. So this question, who solved it? Nobody tried this question. The calculations were very easy. You can do this question orally. Khalid, Zaid, Salman. Okay, Salman has gone. And others who were there, Hania, Samaira, Sneha. Nobody got the answer. BIL, sine 90 degree.
5 minutes.
See, let me solve this question, then you can do the other question. I'll give you people. Force is what? Length of the conductor is like this. Magnetic field is inwards. Angle made between both of them is 90 degree. So that becomes ILB sine 90 degree. I is 5, length of conductor is 10, magnetic field is 2, sine 90 is 1. That makes it 100 Newton. Direction will be direction with the flow of motion of charge, means flow of current. Inwards magnetic field, force will be upwards. So you can write in terms of plus K plus J cap as well, whatever you want. I'm giving you more questions. Then we'll shift on to parallel conductors. But at least try that question. The calculations portion, everything is very easy. This can be the simplest question from this topic. Do this one. Z, just recheck the direction. No, Khalid. Not Zaid. No, no. Recheck, recheck. Myra, this is correct, but you have to find out magnitude as well as direction. Direction also specify, no? Yes, yes. Zaid, right. Now it's right. Others also correct your answers, and those who haven't tried, just submit it. Magnitude is very easy. What does the negative sign signify, Khalid? Mention that direction. If it is signifying any direction, then mention it. Just with just negative sign, no answer is being clear. Hmm. Nahin, nahin, nahin. Khalid, just check once again. Just check once again. Okay, last minute. All of you, please try. Only till now, Zaid has given the complete right answer. Others also just check. See, ILB sine theta is there. Theta is what? Magnetic field is pointing where it is outwards. This dot symbol symbolizes what? That the magnetic field is outwards. So magnetic field is outwards. It's pointing towards me like this. And the conductor is placed like this. So again, the angle made between them is 90 degree. So force will be 5 into 10 into 2 multiplied by sine 90 degree. So force will be 100 Newton. Now again the direction. Keep your hand in such a way that you can curl it towards outwards, because magnetic field is outwards. So I've kept the conductor in the position. I have kept the conductor in the position where the current is flowing up. So I have to, if I keep it like this, then it will be curling inwards. I have to curl it outwards towards me. So if I curl it outwards, this is leading towards the right hand side. So right hand side means what? Either you can put as I cap rightwards, or you can write it as I cap. Any of it. The answer would be correct. Quickly note it down. Then we'll start with force between two long parallel wires, current carrying conductors. This was the correction here. So I think one more class is required. On Monday, we'll be able to finish off this lesson. Then we'll start with the next one. So force between two parallel wires, this is easy. This is one wire I1. This is another wire I2. This is the first wire. This is the second wire. So two long conductors are there. Two long conductors are there. And let's say the separation between them is small d. Conductors with the separation small d are kept. Two long wires. Long wires mean two parallel wires we have taken. Long wires, we have done the case. So remember, if I say force on, we have to actually find out the force on the second wire due to the first one. For that, let's take the magnetic field due to the first one. So if I1 is the current, D is the separation. At second one, conductor is acting at as a point. So what will be the magnetic field? We have done this. These cases we have done, no, initially when we were discussing. Mu naught. No one remembers the magnetic field. It's mu naught I1 divided by 2 pi. That's the magnetic field's value. Just look in and revise it once. Now, force on this second one, or due to the first one, this will be what? Current on this. Let's say L is the length of these conductors. L into B1. Magnetic field will be due to the first one, because if you remove the first conductor, there is no other magnetic field. In the earlier questions where we were doing those questions, we had taken the magnetic field, especially outwards, inwards, anywhere. Right now, there is no magnetic field where you can take it. So if no magnetic field is there, then how will you get the answer? So for that, you have to choose a magnetic field. So magnetic field will be provided by the first conductor. So if first conductor is providing the magnetic field, we have to write B1. Otherwise, you could see the sources of magnetic field right now. B1 will only provide it. And angle, magnetic field due to the first one. Remember, those, if you have to keep your fingers towards the motion of current, curl it, So magnetic field is going outwards. It means making an angle of 90 degree again. So this becomes sine 90 degree. So F21 is basically I2 L B1. Now we have the value of B1. Let's just put it mu naught I1 divided by 2 pi D. So F21, this becomes I2 L. Instead of B1, I will write mu naught I1 divided by 2 pi D. And this will be, the current is flowing. Magnetic field is there. If I curl it, that becomes leftwards. So this is the final formula. Now, okay, one more thing. If I bring this force, bring this length here, means F21 divided by, let me write this formula once again. This is what mu naught I1 I2 L divided by 2 pi D. This is one of the formula. That's it. This is the force on second conductor due to the first one. Now, if I bring this length in the denominator, I will call it as force per unit length. So I'm representing it through small f. That will be mu naught I1 I2. L has been in the denominator right now, so we'll put it without it. This is what? This is basically force per unit length. Now, two conclusions that you have to remember. Two conclusions. First one is that, if two conductors are having the current flowing in the same direction, means the current is flowing in the same direction. See, if the conductors have the current in same direction, they attract each other. If one current is flowing upwards, the other current is flowing downwards, so we say they both will repel each other. Let me write down this point as well. This is an important point. Remember, if conductors have current in, see, for same direction, conductors attract. For opposite direction, conductors repel each other. This is the conclusion that you have to remember. Now, if I am saying F21 is the force on second conductor due to the first one. So if you have to calculate the force on the first conductor due to the second one, that will be simply negative of it. Like the action-reaction forces that you study. All right. So this relation also you have to remember. Now, one thing is there, you can define 1 ampere with the help of this formula only. Let me write down the force per unit length formula. If you have to define 1 ampere. So see, F is what? F is mu naught I1 I2 divided by 2 pi D. So 1 ampere means I1 is equal to I2, which is equal to 1 ampere. If I write distance as 1 meter, what is left? F will be equal to mu naught will be 4 pi into 10 to the power minus 7. This is 1. Here we have 2 pi. So 2 pi gets cancelled. Force becomes what? 2 into 10 to the power minus 7 Newton per meter. Force is 2 into 10 to the power minus 7 Newton per meter. So what is 1 ampere? 1 ampere is basically that current which, when flowing through two long conductors separated by 1 meters, attract or repel each other and produce the force of 2 into 10 to the power minus 7 Newton per meter per unit length. You can define the 1 ampere in this way. If it comes for two long conductors, if the question comes in your board exams, because this question can only come in your board exams, and coming of this question in board exam is very rare. Rarely it can ask you to calculate 1 ampere. So if it asks you, you can write it as by showing this. When to show this, the question will directly say what is the value or how can you define 1 ampere for two long conductors. Fine. So you can show this calculation and then you can make a star point and write it that 1 ampere is that current that flows through two long conductors separated by 1 meter. Separated by 1 meter, produce force per unit length of 2 into 10 to the power minus 7 Newton per meter, which can attract or repel each other. Fine, that's how you can define it. So before moving on to the questions, note down all these points. What if both the conductors are having current in opposite direction will attract or repel? Opposite direction repel, same direction attract. And here in this case, you have to calculate force per unit length. That's why length is not given. Okay. Sorry. See, Khalid, your answer is right. Magnitude is right. Here, 2 into 10 to the power minus 6, you have written. Since both of the conductors which are there, one, we are attracting both the conductors are getting attracted. Reason is that 10 ampere is moving upwards, 2 ampere is moving upwards. Both the current are in the same direction, so they will attract each other. We are right now focusing on the force on the second one. So we'll just see motion of the second one. Second one will move towards the first one. That is minus and cap. So you have to specify the direction. When we'll calculate F21, you can directly write it as F21 will be what? Negative of this. That becomes minus 2 into 10 to the power 6. This is what? This is the magnitude. And regarding the sign, this will move towards right hand side. So that will be I cap, like this. Fine. So note down this is See, basically in this question, you have to find out force on the coil due to the conductor. So I2 is the current flowing upwards, I1 is moving in this rectangular coil. Breadth is B, length is L is given to you. You have to find out the force. See, there are 4 conductors technically if you see in this rectangle. One is this side, other one, if I name, let me name it as A, B, C, D. So AB acts as one conductor, BC acts as one conductor, CD acts as one conductor, DA acts as one conductor. So there will be force here also. So it will attract, this side will attract force AB. There will be force here as well. FBC will be applied here. There will be, both of them will repel each other, no? So this will be force, what is this? CD. This is force CD and this one will be force A. All right. So net force will be what? Net force on this long coil. This will be sum of all the forces. It means F will be equal to FAB plus FBC plus FCD plus FDA. Now, if you look carefully in the figure, AD is moving downwards. BC is moving upwards. So basically, if you see DA and BC, both of them will cancel each other. That this one force and this force, BC. You are left with AB and CD only. Both of them could also cancel each other. One is towards left and towards right. Reason is that separation for force AB is just D, but the separation for force CD, this becomes D plus L. So here is the change in our answer. That's why they are not able to get cancelled. So just look at the force FAB. It is attracting it. So what was the formula that we studied? Current is flowing I1 only in this. So that becomes, and we are calculating force per unit length. No, we are not calculating force per unit length. We are calculating the normal force because length is given. What is this length? This length is given as B. So this becomes mu naught I1, I2. Length is B divided by 2 pi D. And since it is getting attracted, you can write minus I cap plus CD. Everything will be the same. All right, for this conductor CD, everything will be the same apart from D plus L. See, rest of the things are same. I1, I2, everything is there. Length is also B. The separation, instead of D, we'll be writing D plus L. And it will be towards the opposite side, that is I cap. So this becomes mu naught I1, I2B divided by 2 pi D plus L. That becomes I cap. So this is your final answer. That becomes your final answer. Note down this as well. Others have also completed the writing portion.
Yes, ma'am.
Now a very short topic is there. See, two topics are left. One is your magnetic dipole. That's a very short topic, and that's easy. That's very easy. Other one is conversion of galvanometer into ammeter and voltmeter. So that we'll be able to. We need one more class for completion of this chapter. Today we won't be able to do that topic. It's a huge topic that will require one class. So that we'll do in the next class only. Magnetic dipole. See, for magnetic dipole, there's one trick to remember. Whether it's south polarity or it's north polarity, there's just one trick to remember that is very helpful. Even when I do the calculations or I solve the question wherever, if it is clockwise, anti-clockwise, remembering becomes difficult. So what you can do is that you can also learn it in this manner. See, if it goes like this is which direction? Clockwise. So basically, if you write S and go along with it like this. So this is given actually in your NCERT only, this method. So that becomes south polarity. So by this you can remember whenever it is clockwise, that becomes south polarity. In case of north polarity, here obviously, see, once you will draw south, you will see both are not matching. Then you will automatically understand that this is not south polarity. That's why in the first trial only I wrote it as this. You can write n in this form. Obviously, n is written in with straight lines, and now you can write it. See, that becomes south polarity. So this helps you to understand for a current carrying coil. This is for current carrying coil. So this is the way to remember the polarities. But the formula of dipole moment derivation is not included now. Dipole moment of this, not the other one. So magnetic dipole moment, this is basically dipole moment, this is magnetic dipole moment. This is basically number of turns of the coil multiplied by the current multiplied by the area of the coil. N is what? Number of turns, because many a times not a single loop is given. So this becomes what? This is the magnetic dipole moment. Magnetic dipole moment. This is number of turns. This is the current. And this is area of coil. This is I'm telling you for a coil only. So this is for the coil. Now the direction of the dipole moment is also given by the right hand thumb rule. We will be using the right hand thumb rule. So you have to curl your finger along the sense of current, like I'll tell you. Look at this one. Here the current was flowing anti-clockwise. So curl your fingers in the direction of current, thumb gives you direction of magnetic field. So for the first one, this is clockwise, inwards will be the magnetic field. We have done this. I'm just recalling you and making you remember this, that one we use for here as well. And anti-clockwise, so outwards. Similarly, this is the direction also. I'll write it down. I'll write down the direction also. First step is curl your fingers along sense of current. This is the first step. Thumb gives direction of magnetic field, not magnetic moment. We are calculating the magnetic moment here, so it will be magnetic. Magnetic dipole moment. Or even if it is without dipole. But remember one thing, this is also right hand thumb. So don't forget to use your right hand. Right hand thumb rule. All right. Just note down this as well. See, this is a circle given to you. Radius of the circle is given as 1 meter. Current is flowing in clockwise direction. That is 2 ampere. Number of turns is not 1. It is 100 given. So magnetic dipole moment you have to calculate in this question. This will be NIA. Number of turns is 100. Current flowing is 2 amperes. Inwards. Yes. Good set. Try the second part as well. That's a square given. Correct answer, set. So 2 into that becomes pi r square. Radius is 1.
Ma'am, can you show before this question what you wrote? I got
Uh,
disconnected.
okay. Sure. This part, Khalid?
Yes.
All right. Zaid has submitted, I think, the second answer also, no? 8 pi direction is this. Yes, Zaid. Both the parts are right.
Okay, ma'am.
Right? So this will be what? Pi r square. So this is 200 pi. Now direction, it is clockwise, so it will be inwards. Inwards is basically minus k cap. One more thing, SI unit becomes, for current it's ampere, for area it's meter square. That's for the first part. Second part, NIA, number of turns is 100, current is 2 amperes. Area is basically length into breadth. For a square it will be a square, so that becomes 2 square. 2 into 2. So this is directly 800 and this is anti-clockwise, so that becomes outwards. K cap ampere meters. All right, note down this. I'll stop here. I'll not move forward. Just note down and text me when you people, all of you have written.